Here are a couple of examples of some odd things that can happen when we're making our Haworth projections, or going from our Fisher projections to our Haworth projections. So the first example here is what happens if we have a pentose instead of a hexose. So here I'm going to take a look at ribose. Now ribose has a Fisher projection that looks like this. So here's ribose, and ribose has, let's see here, 1, 2, 3, 4, 5 carbons, so it's a pentose, and we have over here the highest numbered chiral carbon atom. The hydroxyl group is on the right-hand side, so this makes it a right-handed molecule, so I'm going to call this one D-ribose, just to show that it's a right-handed molecule. Now, how would we draw this out? This is going to be a 5-membered ring instead of a 6-membered ring. And so it's going to look like this, where I'm going to try to get artistic here. There's my 5-membered ring, and I'm going to put my oxygen up here, and then right here, this right here is going to be my carbon number 1, 2, 3, 4, like this. And then to show that it is a right-handed molecule, we're going to take this group here and put it up above or outside of the ring like this. Like that. And then going around the circle here, we're going to add our hydroxyl groups. And our hydroxyl groups are going to be, if they're on the right-hand side, they'll be going down. And so coming off of the second carbon atom, I'll have it going down, third carbon atom going down, and then over here, which direction is it going to go? And we can't tell just by looking at this, but if I were to call this here alpha D-ribose, so if it's alpha, then that means right here it should be going in the down position, like this. Okay, and then I didn't draw them in, but up above each of these would have hydrogen atoms like that. I was just being lazy. Okay, so here's alpha D-ribose. And then just kind of a vocabulary sort of thing here is this carbon atom right here. This carbon atom right here has a fancy name for it. And the fancy name for that is anomeric carbon atom. Anomeric carbon atom. And if we have two of these ribose molecules, and one is alpha and the other is beta. So if I were to draw the whole thing and then put the hydroxyl group up here, then we would say that these are anomers of each other's. Anomers. So anomers are just the same structure for the carbohydrate. The only thing that makes them different is whether or not this is in the alpha or the beta position. Okay, that would be anomers. Okay, so that there is a pentose. It's kind of forming a 5-membered ring here like this. And I'm going to give you one other example. This one we're going to take a look at fructose. Fructose has a Fisher projection that looks like this. CH2OH. And then here, we'll have our carbonyl group here. This. That, okay. And this one is fructose. You might recognize fructose from like high fructose corn syrup. It's commonly found in fruit, which is why it gets its name fructose. And on this one here, we've got our carbon atoms going 1, 2, 3, 4, 5, 6. And our highest numbered chiral carbon atom with the hydroxyl group is over on the right. So we're going to call this one D fructose. And then I'm just going to make this one alpha here for when we draw it out. All right, now on this one, we have the carbonyl group here instead of up here. Like usually, like the last one, it was like an aldehyde up here, so the carbonyl was coming off of the first carbon. Here's coming off of the second carbon. And this is going to give us a 5-membered ring again. And so the structure is going to be basically the same, where we'll have the oxygen atom like this, and our 5-membered ring going like that. And then if we number these here, well, the numbering is going to be a little bit different. See, here we've got the carbonyl group coming off of the second carbon atom. And so that one's actually going to be here. So I'm going to call this one 2, like this. And say, well, wait a minute, where's this carbon atom? Well, that's going to be up here, like that. So it goes 1, 2, 3, 4, 5, and then coming up here is going to be 6. Like this. Now, let's see, and then putting in our hydroxyl groups coming off of the third carbon atom. It's on the right-hand side, so that's going to be going down. Fourth is on the right-hand side, so that's going to be down. And then this one here is up because it's in the D position. It's D, right-hand side, it's going up. And then this one over here, the hydroxyl group is going to be down, and that's because this here is alpha. So the hydroxyl group is in the down position because of the alpha. And I don't know, maybe I should label this or something here. I'm going to say here this is down because it's alpha, okay? And this is up here because this is right-handed, okay? If that helps to remember things. And then these are in the downward position over here because they're on the right-hand side. All right, so that's just a couple of odd things. So sometimes you can see 6-membered rings, sometimes you can see 5-membered rings with our carbohydrates.